recording here. So that's what as I already explained yesterday, we have gone through all the LINQ example and how we can work with the LINQ in CSharp.net. And today's topic what we have is delegate. So this is a kind of very important question in terms of interview perspective, and at the same time in application development also we are frequently use this concept. So let me try to help you guys to understand the delegate here. Okay, so we know the general meaning of a delegate is representative, right? General meaning of a delegate is a representative. So we can normally call he is the particular company delegate, and he is the particular company representative, like that we are calling. So delegate is nothing but the representative from that particular organization or particular entity. Okay, so here why we are calling the delegate, why I am giving that real like general example here is so company not directly participating in that particular activity. On behalf of company, one person is handling that responsibility. One person is taking care of that responsibility. So that's where we are calling that that particular person, we are calling that delegate of that particular company or representative of that particular company, right?
Yes.
So that's where we are generally called a delegate. Delegate is nothing but a representative. So if I have a company and I'm representing my company, I can call myself can be called as a representative for that particular company. Okay. Similarly, in our C# as well, I have a function. Instead of directly calling that function, if I use some other name or some other method or some other object to call this particular method, that is called a delegate. So I have a method. I want to call that method. But how we can call the method? So if I have a method, I can just call that method with the name of that particular method. And if I want to pass any kind of values to that method, I can pass it. Then it will automatically call and it will print the result. So here, instead of directly calling that particular method with that particular method name itself, we can use some other intermediate object to call that particular method. That intermediate object we are calling as a delegate. That intermediate object we are calling as a delegate. Let me repeat again. So I just gave a general example. So I said like a delegate is nothing but a representative to that particular entity. So that is the general meaning of a delegate. When you come when we explain that concept in terms of C#.net, so if I have a method, how we can call a method? I can call that method with that method name. So and if it is required to pass any kind of a parameter, I can pass it. Then I can get the result from that method. So that is how we are working with the method. Instead of directly calling that method with that particular method name, so if I want to use some other intermediate object to call that particular method, which is called as delegate. Okay, so as I'm explaining the concept, we may have a doubt saying that why we need to use intermediate object to call a method, as I can have an option to call that method directly, right? So we have an option to call that method with the method name itself. Then why I again need to create one object to call that method? So there are a particular advantages are there while working with the delegate. So I will explain one by one. So that's the reason they have introduced the concept of delegate. let me first give the kind of technical example of a delegate. Then we will move with the particular concept of that advantages of delegate. Let's take an example. Okay, so this is the this is a particular delegate example. Okay, so how it is going to call, how it is going to work here is, see here we have a method which is called as print method, and it is accepting one string parameter to, on that same string parameter we are passing to the right line method, which will print the value for that method. Okay, this is the functionality of this method here. So generally how we can call that method. So here itself, so if it is a program class, what I will do is we will create the object for our program class. Program P equal to new program. Okay, P dot. So what is it? It's a static method, right? We can directly call it. We can directly call that method by passing. So something like that, we can pass the string for our print method. So this is the general way of calling a method. So we have a method which is the method name is print method, and it is accepting one string parameter. So how we can call that method? So directly, as it is a static method, we can directly call that method by passing the required string to that particular method here. So this is the general way to call a method. Instead of doing this one, so we are using the delegate object to call that method. Let's see how we can work with that particular scenario. Let's see how we can work with that particular scenario. Here, instead of calling this method directly with this particular method name, now we are using the delegate object to call that method. So let's first see how we can declare a delegate. So let's first see how we can declare a delegate. Here, here is the syntax to declare a delegate here. So as we have the method declaration, it has the access modifier, and it has a return time, and it has the name of the delegate, and it has the number of parameter. It has the number of parameter. Similarly, here also, here we have a uh, access modifier, and one keyword which we are using to declare or create a delegate, which is a delegate keyword, and the return type, and the name of the delegate, and number of parameter. Name of the delegate and number of parameter. So let me repeat again. This is the syntax which we can use to declare a delegate. So how it will work is, it has one access modifier, and the name of the keyword which is called as delegate, and return type, and the particular delegate name, and the parameter. Particular delegate name and the parameter. Particular delegate name and the parameter. So now what we are doing is, this is the declaration of a delegate. Once we declare the delegate, so how we can create the object for a delegate? It's similar to the create the object for a class. So print delegate is my delegate name, and I'm going to create one object which is called as del is the object, by passing the method name. So which method name we are passing? Print method name we are passing. print method name we are passing. So here now if I pass the del by passing the particular string here, automatically this method will call and it will print the output. This method will call and it will print the output. So uh, let me go through the example one more time here. So what we are doing is we have a one method which is called as a print method, which is taking one string parameter, which is taking one string parameter. So the purpose of this method is to get get the string from the particular calling method and to print that particular string. This is the purpose of this method. So generally, how we can call that method is as it is a static method. We can call that method. We can call that method with the method name by passing the required parameter. So this is the one way of calling a method. Now we are discussing the concept of delegate. So here I'm saying that delegate is nothing but the an object which is used to call the method. Delegate is nothing but the an object which is used to call a particular method. Then we have a step process here. Here in order to work with the delegate, we have a two-step process. Actually, three-step process is there. One is declaring the delegate. So how we can declare a delegate? We need an access modifier and a delegate keyword we need, and the return type we need, and particular name of the delegate we need. It's up to our wish. Whatever the name we want to give, we can give it. And parameters, if it requires any kind of parameter, then it need a parameter. Okay, and this is the first step. Second step, what we can do is, as we already declared a delegate, we need to create the object for our delegate. So how we can create the object for our delegate? The name of the delegate and the object name equal to new and the name of the delegate and the passing parameter. Whatever the parameter we want to pass, we can pass it. Basically, delegate will always accept the method name as a parameter. Delegate will always accept the method name as a parameter. So this is the second step. Third step, what we are going to do is with this delegate object, we are going to call the method here. How we are going to call the delegate and the particular name, particular input parameter which we need to point. So how it identify this method only can call this particular print method is here the delegate is while declaring the delegate, we declare the delegate with the input parameter as a string parameter, and at the same time while creating the object for our delegate, we pass our method name. Which method name we pass? Print method name. That's why it identify that it gonna call this print method. Okay, so let me repeat again. So first step what we did is we have declare a delegate. How we can declare a delegate is that access modifier we need, which is public, and delegate keyword we need, and the return type we need, and the name of the delegate we need, and if it needs any kind of parameter, then it need to pass that parameter. So this is the first step. Second step, what we can do with the delegate is we need to create the object for our delegate to accept the method name. Accept the method name which can be called in the third step. Okay, so here how we can create a object for a delegate is name of the delegate and this particular object name and the new keyword and the name of the delegate and parameter which we are going to pass is method name. Now with this object, if I pass the parameter, which method will gonna call? This print method will gonna call. How it identifies only this print method is going to be called? We already mentioned while declaring this delegate object with the method name. So with the method name, whatever the arguments we are passing, that argument we are calling here. So let me try to give one more example here. So this we are writing this. Okay. Okay. So we have two methods here. We have two print method, overloaded print method. One is a print method with the input string, and another one is same print method without having input string, input parameter. Okay. So now if you see, let's put the breakpoint here for the both, and let's try to execute this program. So, and I'm going to execute this one. Will my print method, the second print method is called here, the second print method without having object name. One like from delegate only I got the output. Means this input is passed to this particular string, and here we got the output as a console.writeLine. This from delegate. That that variable here that variable is automatically passed here, and it is printing the output as from delegate. Okay. Will that particular delegate call this particular print method without a parameter?
No.
Is it called this method? No,
No.
right? So if it is called, we should able to
Yes.
see two outputs here. One is from delegate and a
Yes.
test. Okay. So, but it
Yes.
hasn't called this particular method. So why it is because why it hasn't called that particular method is see, while declaring my delegate, I mentioned that it need to accept the input parameter. While declaring my delegate, I mentioned that it need to accept my particular it need to have one input parameter which is the type of string. Okay. After once I declare this delegate, while creating my delegate object, I pass the print method. Even though I have the two print method, so while declaring I mentioned that it need to accept the string parameter. Which is accept the string parameter among these two methods. This one is accepting the string parameter. So that's why this method is calling and this method is not calling here. Okay, so this declaration of a method is need to exactly match with our method as well. So this input parameter and the return type is need to exactly match with your calling method. Then only it will call your delegate. Okay.
Okay.
So that is the purpose of a delegate here. So here we are using this intermediate object to call this method. Here we are using this intermediate delegate object to call this print method. So I can, instead of doing this nonsense, I can directly call my method like this. With simple print that calling that method with the method name itself, we can able to do it. But there are certain advantages are there to work with the delegate. So the first advantage is what we can have is security. The first advantage what we have is security here. So why I'm saying that it's an advantage of in terms of security is so if I give this method to my particular end user by passing this method, is that particular my client or my user know that particular method name? Here we are hiding that method name. We are not giving the method name to that particular end user. We are only giving this delegate object to the end user. Okay, so that we can provide the security for our methods. We are hiding our method name. We are only giving the object name of a delegate, which in turn call the actual method. We are not giving my original method name to the end user. Instead of we are giving one intermediate object which is going to call actual method. So that is the one security advantage we have in our programming. Okay, so let me repeat again. So basically we started with the delegate example. So I told you like delegate is nothing but it's a particular object which can be useful to call a method. So instead of doing that, we can directly call a method with the method name itself. But there are certain advantages are there to work with the delegate. So the first advantage what we have is security. So here instead of directly giving the particular method name to the end user, we are giving the intermediate object name to call that method. So that's why we can able to provide one level of extra security for our programming. For our programming here. Okay, so that is the one advantage, and we do have the two more advantage to work with the delegate. Let's see how we can do that using the delegate concept in C#. So another advantage what we have is multicast delegate. Let's see how we can work with. So other advantage what we have in it in C# delegate is multicast delegate. Multicast delegate. So let's see what is this multicast delegate here. Here we have a one method, sample method 1, sample method 2, and sample method 3. Three methods we just declare, and it's a simple methods only where it has the right line statement print in sample method 1, sample method 2, and sample method 3. Okay, so here whatever the example we have seen in previous example, so we are declaring a delegate. How we are declaring delegate? Our access modifier and delegate keyword, return type, and the name of the delegate. Here we are not passing any parameter. That means whatever the method having without having the parameters that will work for this that will that can be called with this delegate method. That can be called with this delegate method. So now what I am going to do is I'm declaring the 4 delegate object: sample delegate, delegate 1, delegate 2, delegate 3, and delegate 4. For for this delegate 1, I am passing the sample method 1 as a method name. For this delegate 2, I am passing the sample method 2. For this delegate 3, I am passing the sample method 3. Okay, here what I am going to do is for this delegate 4, I am adding all the 3 objects: delegate 1 plus delegate 2 plus delegate 3. Delegate 1 plus delegate 2 plus delegate 3. Now if I call this particular delegate method, so I am just calling this particular delegate method, which internally call this sample method 1, sample method 2, and sample method 3. So instead of calling the each and every method separately, so I am clubbing all the methods into one delegate name. If I call one delegate, it will internally call this 3 delegate methods. Okay, so that is called as a multicast delegate. So a delegate if a delegate can be used to call the multiple methods, then the delegate is called as a multicast delegate. So previous example what we have seen is single cast delegate. With that single cast delegate, we can call only one method. Okay, we can call only one method. For this multicast delegate, we can call multiple methods at one time. So how we are doing that process is we are just declare a delegate. and after that we are creating the object for our delegate, and for each and every object, delegate 1 we are passing the method 1, delegate 2 method 2, delegate 3 method 3. Okay, so now if you see here, for this delegate 4 I'm adding all the 3 delegates, delegate 1 plus delegate 2 plus delegate 3. Now if I call this delegate 4, which is automatically call this all the 3 methods. Delegate method 1, method 2, method 3 will automatically call. So let's see how it will work. So print method, print in sample method 1, which is from sample method 1. This is from sample method 2 and this is from sample method 3. We are able to call the 3 methods, right? With one delegate
Yes.
call itself, we are able to call multiple methods. Okay, so this
Yes.
concept is called as a multicast delegate. So this is the another advantage what we have in our delegates. So instead of individually calling the methods, here we have an option to club or to join multiple methods into a single object. If I call the single object, it will automatically call the multiple methods. That is the advantage of
So,
these delegates. Multicast delegate.
Madanji, in the top one,
Yeah.
which we declare sample delegate
Yeah.
del1, del2,
Mm.
and then at the bottom. So can we declare like this sample delegate del1
Delegate
is
one.
equal to
Yeah,
new
yeah, we
sample
can do it.
method?
We can do it.
Yeah.
We can do it. Like
Okay. Okay.
how we can do it. So let's try that one as well. Here equal to new. We can pass it in. Same.
Okay.
Like this we can able to do that. Okay.
Okay.
So this is the multicast delegate. This is the another advantage of delegate. So first advantage what we have discussed is the security concept of a delegate. So instead of directly giving the method name to the end user, we are creating the one more intermediate object to hold that particular method name, and with that particular method name we are able to call this methods itself. So that is the security advantage what we have, and another advantage what we have is a multicast delegate. So with the one single object of a delegate we can able to call the multiple methods. So that concept is called as the multicast delegate. Okay, so this is the multicast delegate example. This is another advantage. And another very important advantage for this delegate is asynchronous method call. Asynchronous method call. So let's see what is this asynchronous method call. So before explaining the concept of this one, I need to give the synchronous method call and the I need to give the example for asynchronous method call. Synchronous method call, asynchronous method call. So let's first see the synchronous method call, then we will go with this asynchronous method call execution. So what is this synchronous method call is? So let's try to remove all this. Okay, let's try to remove this one as well. This. So here we have a sample method 1, sample method 2 and sample method 3. So how normally we can call this method with the method name. So what I can do is I can call this, and here you can call this. Okay, and after this I can call a method name like this. Okay, so this is how we are calling this methods. Normally in general approach we can call the method like this. So let's talk about the synchronous method call execution. Synchronous method call execution. So what is the synchronous method call execution is, we know in a C# program, how this program will get executed here is, first step 1 will get execute, first line of code will get execute, and once it is complete, second line of code will get execute, and once it is complete, then third line of code will get execute. This is the step-by-step process step-by-step process happening in our C# program. So if you take this kind of example, so if I call this method sample method 1, the cursor will come here. Once it is completely execute, then only cursor again come here and it will call this method 2. Once it completely execute, then only it will call this sample method 3 and it will get execute all the methods. So this is how synchronous method call happening. Let's try to see how it will work here. I place 3 breakpoint for each of my method, calling method and the called method. So let's try to execute the program here. So first it move to the cursor will automatically move to this first line of code. I'm just click on continue button. So where it goes? Sample method 1 it goes. So once it is done, where method function, sorry, this cursor back here, sample method 2. So once it is again I'm going to click on continue. Once it is once I click on continue, it calls this sample method. If I hold here, we'll call this method. No, right? So I'm going to click on continue button, continue button again, and it is going to call the third method. Okay, and it is calling this method. So with this example, what we understand, so the method which we have created will execute one step-by-step process. First, this method, this statement will call. As this statement will call, automatically this method will get execute, and it will come. The cursor will take care of the second line of code, and once it is done, it will take care of third line of code. This is the step-by-step process, step-by-step execution process of a C# program. Okay, this process also called as a synchronous method call. Synchronous method call execution is a step-by-step execution of a method. So first method 1 will get execute. Once it is complete, then only method 2 will get execute. If it is once it is complete, then method 3 will get execute. So this is called a synchronous method call execution. This is called a synchronous method call execution. So after that, so we have now when we come to this delegate advantage, we have one more advantage which is called as asynchronous method call. Asynchronous method call means with this delegate, if I call a method asynchronously, it will not wait for the method execution process of another method. So how it will work is, so let's see how, let's take that example, then we can able to understand. So just remember this example to make sure that will helpful to understand the asynchronous method call. So did you guys understand this approach?
Yeah, by this we understood that we are executing a method step by step.
Yes, sir.
A method needs to be completed first, then after that method 2 will complete.
Yeah. So this concept is called as synchronous method call execution. Synchronous method call execution. Synchronous method call execution. Okay. Now I am going to explain one concept which is called as asynchronous method call execution. Asynchronous method call execution. So let's see how it will work. Similarly, what we are doing is, so with this delegate, I'm just creating the declaring the delegate here. delegate name we are giving it is sample delegate underscore asynchronous. This is the name of a delegate here. And for this delegate, we are going to create three objects: del1, del2, del3. Delegate 1, delegate 2, delegate 3. At the same time, we have the three methods here. At the same time, we have the three methods: m1, m2, m3. Okay. So now, what we are doing here is we are using the asynchronous method delegation here. So now we are using the concept of asynchronous method delegate. So how it will work is delegate 1 begin invoke, delegate 2 begin invoke, delegate 3 begin invoke. We have one method which is called as begin invoke, which accept the following parameter: asynchronous callback and the object. So for now we are not handling any asynchronous callback. So I'm just placing it as null, and the object name also we are going to pass as null. Delegate 1. So previously delegate method name only, like if it requires any kind of argument, that only we pass, and other argument are null only. Here delegate 1 dot begin invoke, which I am passing as a null, and the second parameter also I am passing as a null. Let's place the breakpoint here. Let's place the breakpoint and try to execute the program here. So which method called first? Delegate 3,
Method
right?
3.
Method 3. So, but what we call first here? Delegate 1 only, right?
Yes.
Okay. So let's see the second method. So automatically method 3 will call here. Method 2. Okay. So 3, 1, 2. So asynchronously we are going to call our methods. Asynchronously we are going to call our method. Even in that asynchronous method, one method will not wait for the output of the another method. One method will not wait output of the other method. So see, basically if we remember the previous example, first method 1 need to be complete, then only it will go to the method 2. If something wrong in the method 1, it will not execute here. But in this asynchronous method call execution, one method will not stop the execution of the another method. One method will not stop the execution of the another method. Parallelly, multiple methods we can run at a time. Parallelly, multiple methods we can run at a time with this delegate. Parallelly, we can execute the multiple methods at a time with these delegates. Okay, this concept is called as asynchronous method call, and it will help us to execute the multiple method at the same time. Multiple methods at the same time. So this concept is called as asynchronous method call. So let me repeat again. So assume that let's go to the previous example. So in previous example, what we have is similarly like this. We have method 1, method 2, method 3. We created, and normally how we can call this method 1 name, method 2 name, method 3 name. So if we call a particular method in such a way, first method 1 will call, and if it once it is completed, method 2 will call, and once it is completed, method 3 will call here. So that process we are calling as a synchronous method call execution. So in that synchronous method call execution, one method is dependent on another method. First method 1 complete, then only it will go to the method 2, and if it is complete, then only it will go to the method 3. Okay, so that process we called as synchronous method call. So once we come to the this asynchronous method call with the delegate, it will not wait for the output of the one method to the another method. So it will not wait for the output of a one method. It will continuously calling the methods here. Okay, so again, if you call this method, we are not guaranteed that method 3 first call or method 2 first call or method 3 first call. Let's see how it will work here. So now see, method 1 is calling here, right? Previously, method
Yes.
3 got called. Now when I try to execute the same method, it is calling the method 1. So asynchronously it is calling. There is no particular order here. Okay, so there is no particular order here. Asynchronously, the methods are keep on executing. So that process we are calling as a asynchronous method call. So this is the this is the third advantage what we have with this delegate. Delegate, we started with the delegate, and we I explained the concept of delegate, and after that one advantage what we have seen is security perspective. We have seen one advantage, and another advantage what we have seen is a multicast delegate. With the single delegate object we can call multiple methods. And other advantage what we have is in our delegate is asynchronous method call. So if I want to execute my all methods irrespective of the order at one time, so then I can use this delegate. So this is the one more advantage what we have in the delegate. Okay. So another example what we have is delegate with return value. So delegate with return value. So what is the use of this delegate with the return value is so for example, I have a scenario. I want to execute the method 1, and once it return the any of the value, based on the return value I want to execute the another method. So if the return value is false, I don't want to execute. Condition based, I want to do some operation with the delegate. Then we can use this concept of um, asynchronous method with the return value. Let's see how it will work here. Asynchronous method with the delegate return value. So here what we are doing is we are just creating the delegate with the return value, and previous example what we have seen is delegate with the asynchronous value. And here we are creating the object for our delegate with the return value, and we are creating one object which is called an asynchronous method by passing the null values here. Once I execute this method, so here my method what we have is so this M5 and M6. So this M5 is passing this asynchronous result. Once it is complete, then only it will go to the this particular method 6. So previously what I told you is so if I call the asynchronous method, so we don't have any control when we need to call the first method, and when we need to call the second method, and when we need to call the third method. If you want to keep that control in a program, first method 1 need to call, based on the output method 2 need to be called, and based on the output method 3 need to be called. If I have such kind of a mechanism which we need to implement in our programming then we can use this multicast this asynchronous method delegate with return value. So let's see how we can work it. So we are calling this particular method delegate 5, which is going to invoke the method 5 here. Sorry, method 4 it going to call. Once it is called, then we are checking so whether this asynchronous method is complete or not. We have one method which is called as is completed. Once it is complete, then only it will call that method. So if it is not complete, it will just pass the method saying that not completed. Okay. Once it complete, then only it will call that particular method. So this kind of check we want to apply for our program. Then we need to use this asynchronous method with the return value. Asynchronous method with the return value. Let me repeat again. In previous example, what we have seen is, so here this example, we call all method 1, method 2, method 3 asynchronously without maintaining any condition or without considering the return value of one method to another method. We are not taking care of anything here. We are not considering anything. So we are just giving a call, we are just giving the asynchronous method calls only. So we don't know which method will call first. Okay, so even though we are mentioning this one, first time when we ran our like program, this method called first. Whenever we rerun that particular program, this method called next here. Okay, so if that is the case, if we want to keep some kind of checks, first method 1 need to be called and second method 2 need to be called based on the output. Then what we can do is we can use the concept of this asynchronous method call with the return value. Asynchronous method call with the return value. So how we are doing this process is we are declaring the object similarly, but we are using one more class which is called as iAsynchronous result. So here with this iAsynchronous result, we are checking is asynchronous is completed or not. If it is completed, then only this method. If it is not completed, then only this will call. Otherwise, it will not call that particular method here. Okay, this is the where we can make use of asynchronous method call with the return value. So based on the output of the one method, if we want to call the another method, then we need to go and use this kind of uh, programming, which is called as asynchronous method with the return value. Previously, we haven't considered any kind of return value or any kind of checks. So we are not we are not having any control which method will call the first in our C# program. That automatically decided by the CLR itself. So we don't have any control to give the option this method 1 need to be called and method 2 need to be called and method 3 need to be called. So if you want to programmatically control your particular method asynchronous method call, then this is the only option what we have in our C#, which is the asynchronous method call with the return value. So we can make use of this iAsynchronous iAsynchronous result class to identify whether this particular method is completed or not. So if the method is completed, if you want to do any kind of operation, we can able to do it. If it is not completed, we can keep on working on until that method that method complete. We can loop that particular time. So it will wait here only until method completed. Until method that particular method get executed, it will hold the process here only. Otherwise, if you remove this one, automatically second method will get executed. It is so we are not giving any kind of conditions here. So that's where we are using this asynchronous method with the return value. Okay. So having any questions here, Muzaffar or Raj? So basically, so my intention to explain the concept of delegate is so delegate is nothing but a simple object which can be represent a method. So general example what I gave to you is if I am the representative to the any of the company, so I may call I definitely call as a delegate. Okay. Similarly, in C sharp also, instead of directly calling a method with that method name, we are creating one intermediate object to call that particular method. So that we are calling as a delegate. Okay. Here we have single cast delegate. So with that single cast delegate, we can call only one method. Okay, and coming to the advantages of a delegate, one first point what we have discussed here is the security concept. In terms of security perspective, so instead of giving the actual method name to the end user, we are creating one intermediate object. From that, we are calling this method. So we are not disclosing our particular method name to the end user here. Okay, so that is the first advantage. And another advantage what we have seen in our delegate is the multicast delegate. So what is this multicast delegate is in C# is if I have a multiple methods, if I want to call the multiple methods at one time, then what we can do is we can club all the methods with the delegate objects. Then if I give a call to my delegate, it will automatically call the all of the methods at one time. So which is called as multicast delegate. That is the another advantage. And third advantage what we have discussed is asynchronous method call. Instead of waiting the execution of a one method to the another method, so we can call our all the method asynchronously. So that concept is called as asynchronous method call execution. Using the delegate, we can able to do that. So even in that delegate, even in the kind of asynchronous delegate, if you want to make sure your methods are calling in a particular order, once method 1 is complete that result, based on that result, if you want to do the any kind of operation, then we need to use the concept of asynchronous method call with the return value. Okay, so those are the concept of
Okay.
concept related to the delegate. Okay, so let's see
Yes.
what we have. What we have another concept. Okay, so another concept what we have is reflection. Another concept what we have is reflection. So let's see what is the reflection here. So reflection is nothing but getting the metadata of a particular class or namespace. Getting the metadata of a class or namespace is nothing but a reflection. Okay, so let me repeat again. We have one concept in C# which is called as a reflection. Reflection is nothing but getting the metadata of a particular class or a particular namespace is called as a reflection. Let's see one example. We can understand that here. Okay, so let's see this example. Okay, so as I already told you, reflection is nothing but getting the metadata of a particular class or namespace is called as a reflection. Getting the metadata or metadata of a class or the namespace is called as a reflection. So let's see how we can work with the reflection here. So here I'm declaring one class with the name test. It has the one variable with the name as a variable, a member variable, and another variable what we have is address, and it has the one more integer so integer property which is called as s number, and it has one constructor which is called as test, so parameter constructor which is accepting the integer value, and it has one method which is called as add method which is taking the two integer values and returning the same returning the sum of those integer values, and it also having one subtract method which is taking the inputs of two integer, and it is returning the subtraction of those two numbers, and it also having one string method, one method which is returning the which is just printing the particular text in the console. So this is the class here. Let's see one more time. I'm just declaring one class. Okay, that class name is test is my class name. It has the following member variables, and it has one property. It has one constructor. It has three methods. One is add method, which will use to sum the values. It has one subtract method which will use the subtract which will give the difference of a numbers, and it has one method which just print the output to the console. So this is my class here. Now let's see how we can work with the reflection here. Let's see how we can work with the reflection. So here type T, type of T. Okay. Now what we are doing is T dot name means that name of the particular object or namespace of that particular object, and T dot full name, T dot assembly, so that all the relevant information we are getting for this test class. For this test class, we are identifying that what is the name and what is the full name and what is the assembly name of that particular test class. That relevant information we are getting here. That relevant information we are getting. And at the same time, what are all methods are available for this particular type T dot get all get methods, which will return the all the method names of this test class. Okay, get all fields. Okay, which will return the all the fields of that particular class. Get all properties. See here we have the properties as well. So if you have the properties, it will list out all the properties. And here we have the constructors. Get constructor, get properties, get constructors. It will list out all the constructors. Okay, and we have some methods like get executing assembly and particular loading that particular assembly. That kind of options also we have. Okay, so let me repeat again. So the purpose of a reflection is very straightforward. It will get the actual class information at runtime. So getting the metadata information of a class at runtime is called as a reflection. Getting the metadata of a class at runtime is called as a reflection. What is the metadata of a class means name of the class, and what are the member variables are there, and what are the properties are there, what are the constructors are there, what are the methods are there. That all information if I want to get at runtime, then that is called as reflection. Okay, how we can get that kind of information is we have a type, we have one keyword which is called as type. With this type type of function we can pass this type, which is a class name here. Test is our class name, and with this T, if I type like T dot name, it will give my class name, which is the test. With this T, if I give the full name, it will give the complete full name of my class. If I give the T dot assembly, it will give the entire assembly of a particular test class. And we have one method which is called as get all methods, which will return the all the available methods in our test class. And here we have a fields. It will return the all the member variables for that particular class. Here we have a properties which will return the all the member variables which are declared in that particular test class. So here we have a one more method which is called as a get constructor, which will help to get the all the constructors available in our test class. That kind of information we can get in runtime, which is nothing but a reflection, here. Okay, so let's try to comment these lines of code and execute that, and we can see the information, and slowly we can go to the below section as well. Okay, so here is the class which has the following member variables and the properties, constructor and the method. Here we are getting the
That
name, full name, assembly, get all methods, get all fields, get all properties, and get constructors. Let's see what will be the output here. Sorry. So control dot right line. Sorry. Okay. So let's see the one by one here. What is the uh, output of this t dot name is test. What is the full name? T dot full name is nacook dot test.
cook
So why
that
it is display that nacook dot test is it's display under the
names.
namespace of nacook. Okay, so that's why it is coming like this. And if you see after that what we got, get assembly. So let's see what is the assembly information which we got. So that complete assembly information. So our project name is practice and that version and cultural and public key. That all information we have. And after that get all methods. What is it? Yeah, get all methods dot m dot name. So what we have, get s number, set s number. So those are the two methods which we have declared in our properties.
Property.
Get s number, set s number. And at the same time, we have the add method, we have the subtract method, and we have the show method. And at the same time, we have by default, we have the toString method, equal method, get hash code method, get type method. These are all by default, we are getting the information. Okay. And after
Okay.
that, what we got is get fields, we already got this information. Get property, we already got. And get constructor. Get constructor. Our constructor name is, so which is our constructor name? Test only our constructor. So let's see where we got that information. So constructor. So let's see how we can work with this. Get all constructor. Comment out this. So I'm just placing this information and let's see. So void constructor in 32, which is accepting integer parameter. Void dot constructor with 32. So our constructor name is so this is our constructor, which is the same name of our class and which is accepting integer parameter. That's what we got the output. It is not returning anything and it is a integer type constructor here. Okay, like this we can work with the reflection. So basically the fundamental thing what we can understand with the reflection is get the complete information of a particular class at runtime is called as reflection. Getting the
Okay.
information of a class at runtime is called as a reflection. Getting the information or metadata of a class at runtime is called as a reflection. So I will show you one example here. So whatever the intelligence we are doing, that all based on reflection only. See, so I will give, okay. So I'm just declaring one integer string variable, yes, equal to something like this. I'm just typing. Now if I place the dot s dot, we are able to see all the methods, right? What are all methods are available, what are all properties are available, what are all kind of other objects are available, that are all we are able to see here. So that we are calling it as like context option or intelligence support for in the Visual Studio. How they implement this information? Using the reflection only, they implement this information. Using the reflection with this string class, what are all methods we are able to see that they are represented here. So how they actually got that information? Using the concept of reflection only. Previously we were able to see what are all methods are available in our test class, right? Add method, subtract method, and show method. Let's see that one again. So here, so let's get all methods, right? So let's place this Control K, Control U, and let's remove this. Okay. So what are all methods we have? Add method we have, subtract method we have, show method we have. These are basic method, and these are all available like predefined method for each and every class. Okay. So if I see how I got this information, I got this information with the kind of a reflection. So similarly, for this string class as well, they have the list of methods. So how they are representing that list of method in our context menu here is based on the reflection concept. Based on the reflection concept, they are able to see that kind of information here. So did you understand the concept of reflection? Okay. Hello.
Yeah, but basically we are getting the whole, yes.
Yeah.
Basically through reflection we are able to get all information,
Of a
properties and
particular
fields
class.
and
Yes.
of a particular class, constructors, properties, methods,
So what are the
class
things
name.
yes, what are the things available in that particular class? If we want to able to get that information at runtime, that is called as a reflection. Reflection is
But
nothing.
Madan,
Yes.
what will be the advantage of using this reflection in real time?
Yeah,
We
that's
should
what.
not display.
Correct, correct.
Yeah.
Basically, see, for this string object, so how we were able to see it has the all the methods like this. It how we were able to see it has all this information. What are the methods are available and what are the things are available. So they implement this concept through the reflection. They implement this concept through the reflection. If you want to provide this kind of information for your application, not in the Visual Studio. So for your application, as of now, what for us, we are able to see all these methods, properties, and the some other object here. Okay, so but if you see here, if I want to implement this kind of operation or implementation for my class, so as of now it is available for a string class. For my class, if I want to provide this kind of opportunity, then I need to implement I need to implement this reflection in our program. Then only we already implemented, right? I say we already use this get method. So what I can do is if someone put the a dot, if I able to see, if I able to represent all this method with this box, then we are able to do that thing, same thing, right? So basically, if we want to implement or if we want to get the particular type or class information at runtime dynamically, that is called as reflection. So that is called as reflection. So the advantages of reflection is two ways we have two advantages are there for the reflection. One is If you want to implement this kind of a context menu for our class, we can able to do that. Basically, how we can able to do that? We do have an option here to get all the methods or all the properties or all the constructor, that if I able to represent in a drop down here, that I can able to implement it. Okay, so that is one advantage. And another advantage what we have is in some cases I will give an example. So if I want to integrate some PayPal DLL into our particular web e-commerce website, I can get the DLL. DLL is nothing but it's a file where I can't see the information. Okay, so let's see the example of a DLL here. See, if you see here, properties, and let's open this one. Okay, practice bin debug. So exer DLL, that's all based on information. Release, it's not release, bin debug. So if you see here, we can able to see this kind of exe file, which is nothing but a DLL. So for this practice.exe, if I give this exe to you, are you able to identify what are the methods are available with this particular practice.exe? So basically, we can't directly go and see the information if I just give that information to you. So if I have the reflection concept, what I can able to do is with this namespace, I can load that particular assembly into the particular class, and from that I can get the what are the all options are, or what are the all methods are available, what are all properties are available, and what are all constructors are available. In that way also we can able to use this reflection. So two ways. What is the first way? We can able to implement the context menu for our normal class. We can able to implement the context menu. At the same time, if I have a DLL, if I want to get the what are all classes, or what are all properties, or what are all methods, or what are all constructor using in that particular DLL file, then we can able to do that one. We can able to do that particular option. Let's say how we can able to that's already I have placed an option here. So here how we are doing this option is so here one of the example. Here is my DLL, my assembly.dll. So what is this? So my assembly.dll. For this, here what here I showed my information under C:(test folder, and under that I placed one my assembly.dll. If I execute this one, get executing assembly, then what it will do is this assembly will load into that particular assembly class here. From that, I can get all the types, get types, what are the length and what are the name. And if I want to execute the particular class information, get assembly, and the type class, get all instances. That all operation we can able to do it. So if I have a assembly, I want to get to know, I want to work with that assembly, what are the methods are available, or what are the classes are available, or what are the properties are available. That information dynamically I want to get. This is the option what we have in our C#. So which is nothing but a reflection. If I have a class, I can get the information. That is the basic functionality of a reflection. If I have a DLL, with the DLL also we can able to get the reflection. We can able to get the reflection information, means basic metadata information of a class. Okay, so that is the concept of a reflection. So reflection is useful to get the metadata of a particular class at runtime is called as reflection. And other advantage what we have is if I have a DLL, if I want to get all the details for that particular DLL, then I can use this reflection concept to get the information of a DLL. Okay, so this is the another advantage of a reflection. So let's see the another concept. So the another concept what we have is a threading concept. Let's see how big it is. Foreground thread and background thread, thread life cycle and output interface. So if we have like half an hour of time, then I can continue, or else we can do it for the next session. So it's your convenience. I can available for now, and if you are okay, then I can continue it. So we have one more concept in C Sharp. We almost done with the C Sharp. So this might be the last concept what we have in C Sharp. So this concept which we are calling it as multi-threading or threading. Multi-threading or threading, which is similarly related to the multicast delegate. So with that multicast delegate or asynchronous method calling, we were able to do the like we were able to perform the multiple operation at a time. Similarly, with the threading option also, we can able to perform the multiple operation at one time, which is nothing but a threading, which we will usually call multi-threading. Okay, so if we have a time, I can
Yes.
start right now itself, and if you want to continue later point of time, and tomorrow also I can able to continue. Tomorrow in the sense, the next session also I can able to continue. It will take half an hour time to complete this concept. So shall I start?
Is there anything next session to continue more?
No, no, this is the only one we have, threading concept.
Yeah, for me actually time is 12 అందుకని.
Okay, okay. So yeah, let's take this session next week, Muzaffar. So basically, why I'm
Okay, no
stopping,
problem.
yeah, why I'm stopping here is, so whatever the information we covered in the link queue, and whatever the information we covered in the delegate, and whatever the information we covered in reflection, if you guys able to gone through this entire week, then we can start this threading concept as well.
Okay.
Okay, so that's all from
Hello,
my,
Madan.
yes.
So, Madan,